Hello again everyone, welcome back to ptet.chemistry channel. This is the start of section B, which is this three statement kind of question in the Cambridge International A-Level. So when statement 1, 2 and 3 are correct, is option A. Option B is when 1, 2 is correct. When 2, 3 is correct is C. And D is only 1 is correct. So this is the start of this section B topical MCQ for section 9.9, which is just general periodicity in my classification. Because these are categorized by topics, they should be useful regardless of whatever A-level curriculum or regardless of whatever 16 to 18 years old chemistry curriculum you're doing all around the world. Okay, so in this question, it's saying that some organic refuse, that means like rubbish, garbage, is oxidized to form carboxylic acid. So the water becomes acidic and you can destroy aquatic life. So basically you have acids. You have acidic stuff, okay? You want to remove this acid pollution, you need to react. You need to react with the acid, okay? So calcium hydroxide is alkaline. So alkali can neutralize acid because you can get OH minus plus the H plus give you H2O in a classic neutralization reaction. So this is the Ionic equation for any neutralization reaction. Hydroxide plus H plus acid give you H2O. If you go straight to option 1, that is a carbonate. I'm going to write the Ionic equation. So the carbonate can react with acid to give you CO2 plus H2O plus, that's it really, because the salt itself is essentially soluble because it's forming, I don't know whether it's soluble or not, but I can tell you that when you have a carbonate plus acid reaction, this is the classic Ionic equation where you omit the spectator ion. So the gaseous CO2 and the liquid H2O do not dissociate, and these things are not balanced because you see the charges are not balanced. You need 2 of that, and now your charge are balanced, your atoms are balanced. Okay, 2 hydrogen, 3 oxygen, 2 plus 1, 1 carbon, nice and happy there. So that will react with your acid. Potassium nitrate is already a salt and it will not react with these acids, okay? It's just soluble in the water that contain the acid. So that will not help you remove it. So only 1 and 2 is correct, which is option B. In this next question is about SiCl4. So you should know the chlorides of the period 3 chemistry from sodium all the way to chlorine typically. Okay, well at least the chlorides is from sodium all the way to phosphorus. Phosphorus, yeah, group 15. Okay, because the group 16, sorry, not phosphorus, sulfur. Okay, at least those are your case study in period 3 chemistry. Yeah. So what do we have when we have SiCl4? So SiCl4 is a liquid at room temperature and pressure, as they told you. That's because it's a simple molecular structure. So it's got 4 bond pair and 0 lone pair. And because you have 4 atoms, they are exactly the same in this geometry, tetrahedral geometry, where there are no lone pair. So the dipoles get cancelled out, even though you have polar bond, but the molecule is non-polar. Okay? So the molecule is non-polar. That's why you only have weak van der Waals forces between the molecules that you need to overcome. That's why low boiling point. Okay. They told you that in the presence of water, it decomposes. Actually, it's actually hydrolysis. And as part of your case study, you should know what happened there. So when you react with water, you hydrolyze, you break the SiCl bond, and you form this white solid or white precipitate. And you will give off HCl fumes because it's very, very exothermic due to the formation of a large amount of a strong covalent bond. And when you balance the equation, you will get 4 HCl because of 4 Cl, okay? And you will need to balance that with 2 H2O because of the 4 hydrogen, and then the 2 oxygen that get balanced out, all right? So this is a liquid, plus the liquid, you get this white precipitate, and you get this as a gas, all right? Because of the very exothermic reaction. But what do they want? They want something simple. They don't really want this. I'm just giving you this information based on this. But realistically speaking, they only want what type of bonding occurs in SiCl form. This is a normal covalent bond. The SiCl are normal covalent bond. Number 1, coordinate bond refers to dative covalent bond. And you should know that dative covalent bond is things like when you have ammonia molecule, when you form ammonium ion, that become 109 degree, and it has a plus charge because you use the lone pair on the nitrogen to pick up a proton. The NH3 acts as a base, it picks up a H plus, it accepts a proton. Both the electrons in this covalent bond come from the nitrogen. That's why there's an arrow from this nitrogen to the H. Okay. There is no dative covalent bond here. These are all normal covalent bond because silicon is in group 14. 1, 2, 3, 4 outer shell electrons. Alright. 2 is correct, 1 is wrong. The answer must be 2 and 3. In fact, you know, van der Waals forces, as I mentioned, exist between the molecules. Alright. So 2 and 3 are correct. That's option C. In this next question, it's asking you what is correct about the third period elements from sodium to argon and their compounds. Typically, we talk about the oxides and the chlorides, which are your case study, stated in the syllabus or the specification. In fact, I think most A-level syllabus, all of the A-level syllabus will have covered the oxide and the chlorides of the period 3 chemistry. Yeah. If you look at number 2 first, it says aluminum oxide is the only oxide insoluble in water, and that is wrong because you have Al2O3 and SiO2, both of which are insoluble in water. And that's why both of them, when you dissolve it in water, they won't dissolve and the water simply remain pH 7. Okay, so number 2 is wrong. There can only be one correct answer. Okay, but let me just show you why number 3 is wrong as well. Maximum oxidation state across the third period is shown by silicon. So there is silicon plus 4. You can have it in SiO2, SiCl4. But when you go to group 15, you can have phosphorus plus 5, such as P4 or 10. That is phosphorus plus 5 times 4 is plus 20. Minus 2 for each oxygen times 10 is minus 20. So balance out, okay? The other one, of course, is PCl5. That is, each chlorine is minus 1. Then the phosphorus is plus 5 because the whole molecule has no oxidation number, meaning it's 0 oxidation number for the whole molecule. That's why number 3 is wrong. Even though I don't really have to check for it because I checked for number 2 first, and I know number 2 is wrong, there can only be one correct answer. And we know that electronegativity increases across a period. Okay, so from left to right, electronegativity will increase, so it becomes more electronegative anyway. In this next question, these are from the June 06. Back then, they still used the Roman numeral to represent it in the exam question. These days, you will have come across it as group 14. That's the new type of classification. Not really new, really. It's just that the Cambridge International body has adopted a new periodic table. So now the periodic table has shown you as not the Roman numeral. You kind of have to follow the new notation, yeah? But group 14, group 4, well, these are the old Roman numeral group 4, but we call it group 14 now. So what happened down group 14 is that the bond length increases. Why does the bond length increase? As you can see from the data there, okay? Why does the carbon-carbon, silicon-silicon, germanium-germanium bond length increase? Well, you have more shells. That is the whole idea. You have more filled electronic shell down the group. Very common, right? And as a result of it, your atomic radius increase. Your atom gets bigger and bigger, so obviously your bond gets longer and longer, okay? Your orbital, if I now check number 1, your orbital overlap decrease, okay? So when we talk about the covalent bond, so we need to overlap the atomic orbitals, okay? Either by hybridization or just by overlapping the atomic orbitals, okay? They decrease down the group, so when your orbital overlap decreases, your bond strength decrease because the electrostatic force attraction between the bonding electrons there and the nucleus, they get weaker when your orbital overlap lesser and lesser, okay? So that's going to contribute to bond strength, and it does not explain bond length, okay? Bond length is due to size, okay? So I have a feeling that, okay, so 2 is correct. 1 is a bit dodgy. Nuclear charge increases down the group. I don't know how to explain this. Let's see. So nuclear charge increase down the group. That doesn't explain the bond length increasing at all, because that simply shows that nuclear charge is increasing. I think if I have to choose between 1 and 3, I will go for number 1, because at least bond strength decrease. That would tell me the bond length will increase, because you will have realized that in the syllabus and specification, you need to relate bond length and bond strength. So here, relating the increase in bond length comes from a result of bond strength as well. So I will go for 1 and not go for 3, even though 3 is a correct statement, but it does not explain this idea on bond length. Okay, so I have to go with 1 and 2 only. This is the last question of this 5-question series for general periodicity. So it says that which of the following oxide, when you add it to water, will not, okay, this is a negative observation, will not cause a change in pH. If I look at number 2, SiO2 is insoluble in water. So your pH will remain 7 because they will be insoluble in water. So your pH remains 7. Therefore, no change in pH. Will not change in pH. That is correct because the pH remains 7. So essentially, we are looking for stuff which are insoluble, the oxide which are insoluble. So the same deal with that, Al2O3 is also insoluble in water. So the pH remains 7. And P4O10 is soluble in water. And you should be able to write a balanced chemical equation because they like to ask you in theory paper. So this is phosphorus plus 5, the oxidation state, as you have learned from being able to work it out. Yeah. Okay. So you have 4 phosphorus plus 10 oxygen. Each oxygen is minus 2. The overall oxidation number is 0 because there's no charge. So 4 phosphorus is plus 20. Each phosphorus is plus 5. You are going to form something which is plus 5. You are going to form an acid which has phosphorus plus 5. You are going to have H plus, and you have to form H3PO4, 3 minus, because the LCM, the lowest common multiple between 1 and 3, is 3. So you need 3 of these to balance out the charge of that. When you work out the oxidation number of phosphorus in PO4 3 minus, each oxygen is minus 2, you have 4 of it. It's a phosphate. This is called a phosphate, which you have learned in GCSE or O level as part of polyatomic ion. Okay, so your formula will be H3PO4 and not H3PO3 because of the oxidation number not changing at all. You have 4 phosphorus, so 4 phosphorus. You have 12 hydrogen, no hydrogen there, so you need 6 of it there. And now you have 10 oxygen and 6 oxygen. You have 16 oxygen. So the equation is balanced. All right, but that is an acid. You will definitely get an acidic environment. That's around pH 2, pH 1, very strong acid. Only 1 and 2 is correct. That's option B. Do you have to write this out in the MCQ? No, you don't. Why am I writing it out? Because to do your MCQ, you need to have a strong idea of a theory, right? So that's why when you go through MCQ paper, it's a very good revision for your theory as well, because you are testing more than just your luckiness, okay, in choosing the correct answer. That's not how it works, yeah? So thank you for watching. See you in the next video. Don't forget to subscribe to the channel if you haven't. And check out my other grad playlists and share the channel with your friends, your class group chat, your juniors, your seniors in school, and many more people. Okay, thank you.